So today we're in part 2. We're going to start part 2, which is multiplication. So today we're going to start section 5, which is the distributive property. We're going to build on the skills you learned in part 1 to simplify expressions. So remember, you're going to still need these things, adding and subtracting integers. If I'm adding two things and they're both negatives, if I'm adding two negatives, it's going to be the opposite sum. It's going to be add those two things and use the negative sign. Okay? If you're subtracting two different numbers, you're going to change it to an addition problem. So A minus B is really A plus the opposite of B. Okay? And so we're going to continue to use that in this section. The property of opposites. This was one of in the property of an opposite sum. We're on your quiz. You know, any number added to its opposite, A plus negative A, any number added to its opposite is going to give you 0. Okay? And if you have the opposite of any quantity, any sum, that's just the opposite of the first plus the opposite of the second. Okay? And we're going to use that in today's property. Okay. So today we're going to learn two new properties, and it's the distributive property. There's one property, but we're going to break it into sort of two sections. And these are going to be super important. You're going to use these for the rest of the year, this distributive property. I'm going to show you how to use those properties to simplify these expressions that we're going to do today. And then I'm going to help you to use these properties, and we'll do a few of those together. And then we'll give you another worksheet so you can try these on your own. And then you'll have your homework assignment, which is posted. And so hopefully you'll be able to get at least 75% of those questions right based on today's lesson. Okay, so the first property we want to go over today is the distributive property of multiplication with respect to addition. So they break the distributive property up into two parts, whether you're doing it over a addition sign or a subtraction sign. But the whole thing is really the distributive property. So we told you before, when you're doing proofs or when you're answering questions, for things like the associative property and the commutative property, you need to add whether it's of addition or multiplication. When you're talking about the distributive property, you don't have to write all the rest of this stuff. That's why it's in sort of parentheses of multiplication with respect to addition. That tells you kind of how we're going to go over it, but we're just going to call it the distributive property. So both that we go over today are really just the distributive property. Okay? And this is how it works. It says that if you have real numbers, imagine if I had a box. You'll have to use your imagination for a minute because I didn't bring a box of Snickers in. But if I had a box of Snicker bars and I went around the room and I gave every single person a Snicker bar, and I gave everybody one, yeah, that'd be a good lesson. Maybe we'll do that at the end. And I did that. Basically, I'm distributing. I'm giving out to all of you. So you're all in the group. I wouldn't leave anyone out. In other words, I wouldn't go around and give everyone a Snicker bar but not give Desiree one. I would give her one too. I would give all of you one. So that's the way I want you to think of the distributive property. Everybody in the group is getting something, okay? And so when we talk about groups in math, we're talking about these parentheses. So if I have B plus C here, and I'm going to multiply, because we're on the multiplication section, remember, when you're multiplying something by a letter or a variable, we don't use that little dot symbol. All we do is put it next to it. So when you just see the letter next to it, that tells you you're multiplying. You're not going to see the little dot. The only time we use the dot is if it's between two numerals, okay? So when we're multiplying something by an entire quantity, that means I'm going to distribute this number that I'm multiplying to everything in the quantity. So everything's going to get distributed to. So it works like this. I'm going to multiply A times B, and I'm also going to multiply A times C. So both of these are going to get the A, okay? And you have the addition sign in between. Is everything okay back there? You okay? Just making sure. All right. So we have A times B plus A times C. So our plus sign is going to multiply our A on both sides. And it works. Multiplication is also commutative, just like we studied before. So that means that if I multiply in the front or the back, I can move it to either side. So this is the same thing over here. B plus C times A. I'm just distributing it this way. So it would be BA times, or plus CA, I'm sorry. All right, so let's see how this works with some actual numbers, because I think that makes more sense to you guys than seeing the letters. So let's see. If I'm going to multiply the sum of 2 plus 4 times 3, I know what you're thinking. The first thing you're thinking is, why not just add the 2 plus 4 to get 6, multiply by 3 and get 18, which is our answer. And that does work. If we do our order of operations of the parentheses, you could do that. The reason I want to teach you the distributive property of these easy ones is so when we add in variables, you'll know how to do it. Because you're not always going to be able to add the things in the parentheses. Because you don't know how to add 7 plus x, because you don't know what x is. Okay? So that's why I'm doing it sort of longhand in the beginning, just so you can see this with simpler numbers. So if I'm multiplying 3 times the quantity of 2 plus 4, I'm first going to multiply 3 times 2, which is right here. And then I'm going to multiply 3 times 4, which is right here, and add those products. All right? And so if I multiply 3 times 2, it's 6. And if I multiply 3 times 4, it's 12. And so I come to the same 18 that I talked about if you just did it simply in the beginning. Okay? But what if there's a variable? So this is why we're going through this. So here I have a quantity of x plus 7, and I'm going to multiply that by 3. So I have to multiply 3 times x, which is just 3x, because I don't know what x is. And then I'm going to multiply 3 times 7, which is 21. And my answer is 3x times 21. Now remember, when I'm going through some of the homework, some of the independent sheets, I'm noticing that some of you, a few, are still adding these together, and I'm getting something like 24x. So it's really important that you remember you can't do that. If you have a numeral and a variable expression, they just stay by themselves. You can't add x's and numbers. That's like adding apples and oranges. You can't do that. Okay, so I want to make sure when you have one variable and one numeral, you just leave it just the way it is. That's all you can do. All right. Let's go through a couple of more examples here. What if I do the distributive property backwards? If I asked you guys off the top of your head, if I said, Tim, what's 48 times 6? You probably couldn't give it to me like that. Maybe you could because you just saw it down here. But before you saw the 288 there, you don't know what that is. You'd have to get a longhand or get a calculator or so and do that.
Well, I could do it in my head, but it'd take a while.
It'd take a while. But if you think about it like this, it's a lot easier. If I take a 6 out of that, and what's 48 really? It's 48 is just 40 plus 8. And I can put that there because of what? What property lets me substitute 40 plus 8 for 48?
Substitution.
The substitution property. So 40 plus 8 is the same as 48. And if I distribute that, now it's much easier to add. Because 6 times 40 is just 240, because you can multiply things with a 0 at the end pretty easy. You just take 6 times 4 is 24 and add the 0. So it's 240. And you know what 6 times 8 is? It's 48. So when you add 140 and 48, you get 288 pretty easy without doing a lot of longhand division. Okay? What if you have a decimal? Well, again, if I multiply 4 times 3.25, you probably don't immediately know what that is in your head. But all 3.25 really is 3 plus 0.25. So if I know 4 times 3 is 12, and I add 4 times a quarter, and 4 quarters make $1 or 1, well, 12 plus 1 is 13. So I can do that fairly quickly using the distributive property. Now fractions, these are what everyone loves, right? Well, if you multiply 6 times 4 1/3, again, that might not jump out to you what the answer is. But 4 1/3 is really just 4 plus 1/3. And if you have 4 plus 1/3, you multiply 6 times 4 to get 24. If you multiply 6 times 1/3, well, 1/3 of 6 is 2. 24 plus 2 is 26. Okay. Now for the variable expression, because this is the ones that sometimes you'll look at this and you'll stare at it for a few minutes and think, well, what do I do with that? Well, 3x plus 4 times 2. That just tells me that I'm going to multiply 2 times 3x and also multiply 4 times 2. And I draw the little arrows still. So you want to do this if you need to. And this will just give you a little reminder of where you're going. I'm sorry, I hit that. So 3x times 2, 6x. Now notice that you can multiply your variables into your numerals because all 6x really is 6x's. It's not the same. And so basically what I'm adding together is x plus x plus x plus x plus x plus x, which is 6x. Okay? I'm not adding, I couldn't add 3x plus 2 and get 6x. Or get 5x, I'm sorry. But I can multiply those because I'm really just adding a string of them. And then, of course, you know what 4 times 2 is. It's 8. And so we have to stop here. Once we get to the addition part, we can't combine anymore. So 6x plus 8 is really all we have. All right. So now let you guys give it a try. You want to go first? Okay. 7 times 28. What am I going to do? Do you know what that is in your head? Don't try to figure it out in your head. I want to try to do it using the distributive property. What's another name for 28? What can I substitute for 28?
20 and 8.
20 and 8, okay. 20 plus 8 works well. What's 7 times 20?
20 is 140.
140. What is 7 times 8?
56.
56. And so now, what is 7 times 28?
196.
196. Very good. Okay, who wants to go second? Any volunteers? Gianna, you. Okay, great. So, fractions. So I have 12 times 2.5, I'm sorry, 12 times 2 and 5/6. Do you know what that is off the top of your head?
No.
Didn't think so. But what could I substitute for 2 and 5/6 that you might know? What two things could I add together that would be the same as 2 and 5/6? Start with the whole number, 2, right? And what would I have to add to 2 to get 2 and 5/6? 5/6. Good. Okay. What's 12 times 2?
24.
24. Now this one's a little tricky, right? What's 12 times 5/6? Well, this is really just 12 over 1, right? Because when you have a whole number, it's 12 over 1. And so, if I'm going to multiply those, I just multiply across the top and multiply across the bottom. So what am I going to get for my fraction? What's 12 times 5?
60.
60 over what?
6.
And what is 60 over 6?
10.
What's 10 times 24?
240.
Very good. Okay. Hojin, you okay? Weston, 6 multiplied by the quantity y plus 7.